Today we are going to talk about rate of change, or another name for an average rate of change. The rate of change, as you remember from grade 9, is the slope of a graph. And we define the rate of change as how fast something is changing. Now, the average rate of change is the change of the value of a variable divided by the time it takes the change to take place. Usually, the average rate of change is the slope of the line. The slope of the line, as we know, is the rise over run, or if you take 2 points on the line, is the difference between the y-coordinate of the 2 points divided by the difference between the x-coordinates of the 2 points. What I mean is that if you take 2 points, let's say here and here, if this point has the coordinate x2, y2, and this point has the coordinate x1, y1, then we define the slope as the difference between the y-coordinates y2 minus y1 divided by x2 minus x1, or the rise over run. This is called rise and this is called run. Now we are going to do a couple of examples here. If I give you a table of values like the one shown here, the question is that how do you find the rate of change or the slope of the line? By definition, slope is y2 minus y1. Let's take this point to be 0.2 and this point to be 0.1. Then the slope, which I show it with m, is y2. y2 is 1400 minus y1 is 2000 divided by x2, 4 minus 0. 1400 minus 2000 is going to give me negative 600 divided by 4 minus 0 is 4. Now, negative 1600 over 4 is negative 150. So negative 600 divided by 4 is negative 150. This means that the slope is negative and is the rate of change, which is negative 150. This means the height of the plane decreases but by 150 meters every minute. The next example is the graph in B. You're supposed to find the rate of change or the slope of this line. Again, we are going to take 2 points as the reference. The first point, we can take this point, and the second point, we can take this one. Now, the order does not matter, which one is 0.1 and which one is 0.2. Let's suppose this time I'm going to take this one as 0.1 and this one as 0.2. Then the slope m is y2 400 minus y1, which is 700, divided by x2, which is 200, minus x1, which is 400. Now 400 minus 700 is negative 300, and 200 minus 400 is negative 200. The answer is going to be 1.5. This means that the cost increases by $1.50 for each kilometer driven. Now remember your slope or rate of change. The unit is the unit of the numerator divided by the unit of denominator. The unit of the numerator is the kilometers divided by the unit of the denominator, which is going to be dollar. And since the slope is positive, it's increasing. Now we are going to define two new terms. The first term is called the reaction distance. If you are driving the car, as soon as you see a car in front of you, the time from the time that you see the car to the time that you apply the brake is called the reaction distance. Now, depending on how far is the car in front of you or how fast you react, this reaction distance is different for different drivers. So the reaction distance is the time that it takes you see the car in front of you to the time that you apply the brake. The next term is the braking distance, is the distance that the car travels since you apply the brake to the time that it stops. So as soon as you see the car, you brake, and the time that it stops is called the braking distance. Now we are going to the next example. We have two tables here which shows the reaction distance and braking distance, which is reported for a car on a dry pavement for different speeds. For instance, for the first case, it shows that when the car is traveling at 50 kilometers per hour, the reaction distance is 10 meters, meaning that the driver notices the car in front of it, and the time that it sees the car and it applies the brake is 10 meters. At the same distance, 50, when it applies the brake to the time that it stops the car is 12.5 meters. Now let us find the rate of change or the slope of the reaction distance and speed, meaning the slope of the first table. The way you find the slope of the first table is you find the slope of every consecutive points here in the table. For instance, the slope of the line between these 2 points, slope is going to be given by 2 minus 0, y2 minus y1, y2 minus y1, divided by x2 minus x1, 10 minus 0, which is 0.2 meters if I find the rate of change between these consecutive points, I'm going to find the slope m is 4 minus 2 y2 minus y1 divided by x2, 20 minus 10. which is going to give me 2 over 10 again, which is 0.2. If I find the slope between these 2 points, I'm going to get m is 6 minus 4 divided by 30 minus 20, which again is going to give me 2 over 10, which is 0.2. As you can see, the slope here is all the same, which is 0.2 meters, which shows that the reaction time is going to increase by 0.2 meters for every 1 kilometers per hour increase in the speed. Now we are going to find the slope or the rate of change for the second table, which is the braking distance. Again, to find the slope, I'm going to pick 2 points and then find the difference between y's divided by the difference between the x's. So again, let's take 2 points here. So the slope, by definition, is y2 minus y1 over x2 minus x1. So y2 is 0.5 minus y1 is 0 divided by x2, which is 10, minus x1, which is 0. So it's going to be 0.5 divided by 10, which is going to be 0.05, which is going to be meters. For the next 2 points, these two, the slope is y2, which is 2, minus y1, which is 0.5, divided by x2, 20, minus x1, which is 10. Now this is going to give me 1.5 over 10, and 1.5 over 10 gives me 0.15. For the next 2 points, m is 4.5 minus 2 divided by 30 minus 20, which is going to be 2.5 over 10, which is going to be 0.25. As you can see, the slope here is increasing. What it's telling you is that as the speed of the car increases, the rate of change also increases. This means the braking distance is increasing. Again, in another word, is that as your speed is increasing, the time it takes for the car to stop after you apply the brake also increases. I will leave finding the rate of change for the last 2 points, meaning these 2 points, to you to do as a practice. The next part of the problem is asking us to graph the data in the tables that we saw, the 2 tables. And we have to describe how the graph reflects the rate of change across the data. Now, if we refer back to the table, for the first one, which was the reaction distance versus the speed, when the speed is 0, the reaction distance is 0, which is this point. When the speed is 10, the reaction distance is 2. When the speed is 10, the reaction distance is 2, which is somewhere around here. When the speed is 20, the reaction distance is 4. When the speed is 20, the reaction distance is 4, which is around here. When the speed is 3, the reaction distance is 6, which is going to be here. When the speed is 40, the reaction distance is 8, which is going to be around here. And when the speed is 50, the reaction distance is 10, which is going to be around here. As it is apparent from the graph is a line, is linear. And the interesting part is that the rate of change, as we found before, was constant. This is a fact about linear relationships. The rate of change is the same or constant and does not change. Now we are going to plot the second table, meaning the speed versus the stopping distance. When the speed is 0, the stopping distance is 0, which is the origin. When the speed is 10, the stopping distance is 0.5. Now 0.5 is approximately this point. When the speed is 20, the stopping distance is 2. When it's 20, the stopping distance is 2. So it's going to be around this distance. When the speed is 30, the stopping is 4.5. 3 and then 4.5 is going to be somewhere around here. When the speed is 40, it's 8. When the speed is 40, it's 8, which is going to be somewhere around here. When the speed is 50, it's 12.5, which is going to be somewhere around here. As you can see from the graph, now the graph does not show a linear relationship, but rather a curve. The interesting part again is that if you go back to the rate of change, since the rate of change is not constant, you can see that the graph that you get is not linear anymore. This means that the relationship between variables is not linear. In the next example, we have a table of values which shows the changes in the height of a tomato plant from the time that it's planted until the tomatoes are ripened. The question is, when is the rate of change 0, constant, and changing? To do this one, we know that the rate of change is defined as the difference between the y's divided by the difference between the x's. The difference between the x's is always 2. 2 minus 0 is 2, 4 minus 2 is 2, 6 minus 4 is 2, and so forth. So all of them are 2. Now the difference between the y's. If you remember from grade 9, the difference between the y is called the first differences. So what we are going to do is to find the first differences in the y values. And the y values are the height. So 5 minus 0 gives you 5. 10 minus 5 gives you 5. 20 minus 10 gives you 10. 40 minus 20 gives you 20. 58 minus 40 is 18. 75 minus 58 is 17. 86 minus 75 is 11. 90 minus 86 is 4. And 90 minus 90 is 0. It's very easy to see when the rate of change is 0. The rate of change is 0 only here, which means weeks 16 to 18, the rate of change is 0. The next question is, when is the rate of change constant? You can see that the first differences from weeks 0 to weeks 4 are 5. So this means from week 0 to week 4, the rate of change is constant. Now, the only part which is left is when is the rate of change is changing. You can see that here 10 goes to 20, then 18, then 17, then 11, then 4. So from this week, which is week 4, to week 16, the rate of change is changing. Now we are going to do the next part. The next part is asking when is the rate of change maximum. You can see rate of change is maximum when it is 20. So from week 6 to week 8, the rate of change in the height of the tomato plant is the maximum. The last part of the question asks, how do we describe the growth of the plant? The first 4 weeks, as you can see from the table of value here, the rate of change is constant. Then the rate of change goes from 5 to 20. This means that the rate of change is increasing, and then it starts decreasing for the next 16 weeks until it gets to 0. When it gets to 0, this means that the plant has reached the maturity and it's not growing anymore. To summarize what we have learned so far is that either if you are given a table of values or a graph, we want to know how we can detect the relationship between two variables or two quantities. First, if you are given a table of values, find the first differences. Find the difference between consecutive y values, y2 minus y1. And if a graph is given, look at the graph to see if it represents a line. Now, if the table of value, the first differences is 0, then it means the rate of change is 0. Because remember, slope is first difference is y divided by first differences is in x, but the first differences in y is 0, so rate of change is 0. This means that the graph is going to be a line horizontal and parallel to x-axis, as it's shown here. The second possibility is that the first differences are not 0, but they are all equal. This means that the rate of change is constant and the graph is shown like this one. But remember, this is a positive slope. You can also have the possibility of a graph like this. This represents a negative slope. Still, the first differences are equal. The rate of change is constant, but it's negative. For this, the rate of change is positive. For this, the rate of change is negative. And the last possibility is that the first differences are not equal. They are changing all the time. So rate of change is changing. The first differences are not equal. they are changing, and what you see is that no more linear relationship. You see a curve.